All right, for today, what we're going to do is applications with parabolic functions. So basically for our example, we have the graph at the right shows the height listed as h for our variable in feet of a small rocket for t seconds after it is launched. The path of the rocket is given by the equation h is equal to negative 16t squared plus 128t. So basically, this is the path of the rocket, right? It flies up, gets to a maximum height, and then it comes back down to the ground. So on our y-axis, we have h for our height. For our x-axis, we have time for 1 through 8 for seconds. All right, so the first question is asking how long is a rocket in the air? So all we have to do on this one is, we'll take a look. We go, okay, it starts on this 0 right here. So it starts at a 0, even though it's not listed. And then it goes all the way to 8 seconds is when it hits the ground again. So the rocket is in the air for 8 seconds. Right. So 8 seconds, make sure you put your units on there. It says, what is the greatest height the rocket reaches? So if we look up here, we could try to estimate it, but we can use our graphing calculator. So what I did was I just put in that equation, the negative 16. I used x because that's on the calculator. It only has the variable x. Negative 16x squared plus 128x. So I'm going to put that in. I'm going to hit graph. So it shows me the parabola. And now if I go second and then I hit graph again for table, I can look and see that, okay, it goes from 0 all the way up to 256, and then it starts going back down. So 256 is its maximum height. So when I come back here, I'm just going to write in 256. Oh. All right, 256, that's our maximum height for the rocket. About how high is a rocket after 1 second? Again, all we have to do, graphing calculator makes it really easy. 1 second, it was at 112 feet. So 112 feet. After 2 seconds, it's asking about how high is a rocket. Now, I've been showing you the graphing calculator emulator that I have, and there was a link to, I think, that. But you could also go to Desmos, and if I put this in, right, and I zoom out, it'll show that parabola, right? So this is Desmos. It's online. You can get it. If I go up to this gear wheel, and I go to this part where it says convert to table, so now I can see, what it is. And right now it's only showing up to 2, but if I just go to where 2 is, and I keep hitting enter, it'll keep going. So here we started. It started to be launched at 0 seconds. It went up, then came all the way down again. So that one was asking about for 2 seconds, and we're at 192 feet. So I just wanted to show you the other way. If you don't have that graphing calculator emulator, you can use Desmos. So here we go. Just to show you that 192. So let's write that after 2 seconds, 192. It's saying, is a rocket going up or down at that point? So at 2 seconds, right, we're still going up. And then it's asking after 6 seconds about how high is a rocket. So 6 seconds is right there. That was 2. This is 6. So again, if I grab my graphing calculator and go, okay, 6 seconds, I'm at 192 feet. So when I come in here, 192. And now it's asking, is the rocket going up or down? So at this point, the rocket has already reached its maximum height and it's coming back down. All right. Okay. So that's some of the questions on the parabola. It's saying, do you think the rocket is traveling faster from 0 to 1 second, or from 3 to 4 seconds? And explain your answer. So from 0 to 1, this is this range right here, versus 3 to 4, right? So 3 to 4. So if we had to take a look at that, it looks definitely steeper from 0 to 1 than it does 3 to 4. One way that we could solve this out algebraically is we could use our slope formula, right? And our slope is equal to, remember we said the change in y, or y2 minus y1, all over x2 minus x1. Okay, and from 0 to 1, if we go to our calculator, 0, 0, 1, comma 112. So those are our 2 points. So from this one, it went from 0, comma 0 to 1, comma 112. And then from 3 to 4, let's just take a quick look there. So 3 to 4. So 3, 240, 4, 256. So it went from 3, comma 240 right to the next point, which was 4, comma 256. Oh man, I'll tell you, it's not a video without a. I don't know if I was doing that right or not. Without me making a mistake on these things. 4, comma 256. Okay. So for our slope, what we would do is we would plug in for the 0 to 1. We'd go. I'm going to call this 112 is y2, and the 0 is y1. So 112 minus 0. That's a u. There we go. All over 1 minus 0, right? Because we want to always, the y, whatever we say is our y2, we want to use the same one for our x2, so x2 would have been there. So this would just equal a slope of 102, right? And we would say feet per second. Okay, so at that point from 0 to 1, it's going at, that rocket's going 112 feet per second. And if we put in, right, our slope for this one, we get 256 minus 240. All right, and that's all over 4 minus 3. So we end up with 16 over 1, or 16 feet per second. All right, so you can see just from that definitely from 0 to 1, it is going faster than from 3 to 4. All right. On the next one, again, on the regions, they might ask you to figure this out algebraically instead of using a graphing calculator. So using the equation, find the exact value of the height of the rocket at 2 seconds. We already know when we pulled up our graphing calculator that we're going to be at 192 feet at that point. But this is just asking you to now do function notation, right? And so the first step is you're going to put your 2 in for the t. So 2 goes into wherever you had a t. It's going to be 2 squared times negative 16 plus 128 times 2. The next spot, you're going to square that. So 2 squared is 4. So we're going to have negative 16 times 4 plus 128 times 2 is 256. And when we do that, we get negative 16 times 4 gives us a 64. So negative 64 plus 256 gives us the final answer of 192 feet, which again was what we could get from the calculator, but they want to have you solve it algebraically. All right, so then the question on this packet is, what is the domain of the graph? So the domain is domain is x values. All right. And then our range is going to be our y values. So what is the domain of the graph? So if we pull this over, we get, the rocket was in the air from 0 to 8 seconds. So our range is 0 to 8. The range, what is the range of the graph? So when we look for range, we're looking at y values. Domain, we're looking at x values. So when I pull this over, we get 0 is less than or equal to y, which is less than or equal to 256. So again, that parabola, when it went up, On my y-axis, if I scrunched everything over to this y-axis, it would only go from 256 down to 0. If I flatten this curve all the way down on the x-axis, it would only go from 0 to 8. So that's our range. Saying express the interval over which the graph is increasing. So on this one, if we look, and when the graph is increasing, it's going up, 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 all the way to the vertex. So that is right at 4 seconds. So it's increasing from 0 to 4. And then it's saying, when is it decreasing? So it's decreasing from the vertex down to when it hits the ground, 4 to 8. Okay. I'm going to have you guys use this one. It says it's an example, but I want you just to get a little practice in on Edpuzzle. So use this equation right here to answer any of the questions. Remember to use Desmos, or if you have a graphing calculator, or if you have a graphing calculator emulator, you can use that. All right. And then answer those, and then we'll move on to another example.